Hi, in this video I'm going to talk about the stochastic differential equation for a risky investment. Uh, uh, to start the stochastic differential equation, I'm going to take the initial investment as S0, and after the small duration dt, uh, the value of the initial investment is going to be S1. The rate of return of the investment is going to be a random variable. If you go back to the previous video what I created for the guaranteed investment or the stochastic differential equation for a continuous compounding with a guaranteed return, um, so that is I referred as a mu in the previous video. So that is actually a fixed rate. It's like paying a simple interest or a compound interest when you make a fixed deposit in a bank, where the bank guarantees the return of investment. In that case, you will get the value mu, which is fixed, and that the value is used subsequently for the future calculation of the asset value. But whereas here in the risky investment, which means like the rate of return is not certain, um, so there is a randomness in it. So the rate of return is represented by a random variable y1. So at the end of the dt, the first duration, the return of the investment is going to be 1 plus y1, which is a random variable, times s0, which is the initial investment. So if you take the same approach for the second iteration or the second period, the second period rate of return is going to depend upon a different random variable, which is I named as y2. So at the end of the second period, S2, the return of the investment is going to be 1 plus y2, which is a random variable for the second period, and the value of the investment after the first period. And substituting y1 from here, we get S1 is equal to 1 plus y2 times 1 plus y1 times S0. And if you go for the third iteration, the third period, again this method is going to continue, which means like there is going to be the third random variable for the third period. The return of the investment at the end of the third period, S3, is going to be 1 plus y3 times 1 plus y2 times 1 plus y1 times the initial investment. So if I generalize this as Sn, that is the return of the investment after the nth period, then the rate of return for each period is represented by y1 to yn. The S1 is going to be 1 plus yn times 1 plus yn minus 1 up to 1 minus y1 times S0, which is the initial investment, S0. So here I'm going to generalize. So I'm going to generalize it by saying Sn is equal to the multiplication of 1 plus yi times S0. Um, so to simplify this, I'm going to take a log on both sides. So this is a log Sn is equal to log of um, uh, the multiplicative of 1 plus uh, yi times S0. So then when I take a log, it then becomes a summation here. Um, so then I am going to take this log S0 to the other side. Then it becomes a Sn divided by S0, log of Sn divided by S0. So since this is a multiplication, say this is a log, this is equivalent of log a times b times c, that is equal to log a plus log b plus log c. So that's basically what I did here. So I changed the log to the summation of log 1 plus um, yi. Uh, then I'm going to replace this whole log 1 plus 1 plus yi is equal to z. That means log Sn divided by S0 is equal to summation of I tends to 1 to n zi. So here zi is normally distributed with identical mean and variance. So I'm going to say the mu is equal to the expected value of zi divided by dt, and the variance is defined as the variance of zi by dt. Um, so zi is a normally distributed with mean of mu dt and the variance of sigma square times dt. So with that, I'm defining dxy, dxi equal to zi minus mu dt divided by sigma. So by making the changes here, like the zi is going to be um, sigma times dxi plus mu dt. So that is basically the uh, zi, and in the previous page, or in the previous section, we said log s of t times s of 0 is equal to summation of I from 1 to n zi. Let's say st be the value of investment at time t, and dt is equal to t by n. So actually I will take an example in the next video where all these things will make a lot more practical sense by taking actual data. But go along with me to understand the concept so that I can show the difference of a risk-free and risky investment stochastic equation, and what is an extra parameter which is going to be introduced in the risky stochastic equation. Um, so by substituting the zi here, um, so I'm substituting zi here. Let me change the color. As I'm substituting zi here, um, so then it is a summation of sigma dxi times mu dt. Then I'm going to split the summation between these two uh, variables. So here the summation of mu dt. So there is no, you are basically adding mu dt n times. So it is nothing but n times mu dt. So that's what I did here. Just remove the summation because you are just adding up that many number of times. Is equivalent of multiplying that n times mu dt. So whereas here the dxi is a variable, so that is going to be here, and I'm going to generalize that with xi. So with that said, this becomes n mu dt, and again I'm defining dt is equal to t divided by n. That means n dt is equal to t. So that is what I substituted here, mu t plus sigma dxi, summation. Again, sigma is a constant and it is outside the summation. So here I'm going to take this dxi summation of 1 from summation from I equal to 1 to n as x. By substituting that value here, so I get log s of t divided by s of 0 equal to mu t plus sigma x, where x is a random variable normally distributed with the mean of 0 and the variance of t. So now we want to find out the s of t, which is the value of the investment after time t. So for that I'm going to take to the power on both sides. Then it becomes s of t by s0, then e to the power mu t plus sigma x, and I'm taking the s0 to the other side. Then it becomes s of t is equal to s0, which is the initial investment before dt, times e to the power mu t plus sigma x. So if we want to know the variance of the investment between a given duration, like I did in the previous video, so I'm going to take a ds of t, which is s of t plus dt minus s of t. Then that I'm going to take the value of s of t from here, and s of t plus dt is nothing but I'm going to introduce change the value of t by t plus dt here. Then by just simplifying this equation, it becomes s of t times e mu dt plus sigma x minus 1. So then to generalize this, uh, this is basically the stochastic equation of an investment with the risky investment, I should say. And this dx is the normally distributed random variable, mu is the mean value, and sigma is the variance, and dx is normally distributed with the mean 0 and variance dt.